Students, we are given this question to evaluate 2 times integral 0 to infinity e raised to the power negative x squared times x raised to the power 2n negative 1 times dx. So foremost, what I'm going to do is I'm going to make the substitution that let x be equal to some square root of t. Now when I differentiate, this is going to be dx is equal to, this is actually t raised to the power half. So when you differentiate this is 1 over 2 times t raised to the power half negative 1 times dt, which can be rewritten as t raised to the power negative half divided by 2 times dt, which is going to be 1 divided by, you can move this down, so that would give you 2t raised to the power half times dt. So this is your dx. Now you can change the limits. So when x is equal to 0, you got t, actually from your t is actually equal to x squared, right? If you square this both sides, you get t on the right and x squared on the left. So when x is equal to 0, this would mean t is equal to 0. And similarly, when x is equal to infinity, this would mean t is equal to infinity squared, which is infinity. So therefore, integral, of course you have a 2 there, 0 to infinity e raised to the power negative x squared times x raised to the power 2n negative 1 times dx can be rewritten as 2 times integral 0 to infinity. In place of x, I would be substituting t raised to the power half. So t raised to the power half with a negative sign, and you have to place a square there. So this is t raised to the power 1 over 2 times x is actually t power half, and that has to be raised to the power 2n negative 1, and dx is dt divided by 2 times t raised to the power half. Now this can be rewritten as 2 times integral 0 to infinity. You get your e power negative t, because it's actually t raised to the power half raised to the power 2, which is going to be t. Okay, and over here it's t raised to the power 1 over 2 raised to the power 2n negative 1, which is going to be t raised to the power, you got actually 2n divided by 2 negative 1 over 2. So this is equal to t raised to the power n negative 1 over 2. This is what you get. So you need to place that there. So this is t raised to the power n negative half times dt divided by 2 raised to the power 1 over 2. Now I can rewrite this by removing the 2 here, and then 0 to infinity e raised to the power negative t. This is t power n times t power negative half. You have a half there, I can take it to the numerator, so that would give me t raised to the power negative half multiplied with dt. So I can rewrite this entire thing, and that would give me integral 0 to infinity e power negative t raised to the power n times, now t power negative half has to be added with negative half multiplied with dt. So that would give me integral 0 to infinity e power minus t times t power n times t power negative 1 times dt. Now these two can be clubbed together, giving me integral 0 to infinity e power minus t times t power n negative 1 times dt. Now we know that, what do we know? We know that integral 0 to infinity e power negative x raised to the power n minus 1 times dx is equal to gamma of n. This is equal to gamma of n. Okay, we know this formula. we also know that gamma of n is equal to n minus 1 factorial. Okay, so this would mean integral 0 to infinity e power minus t times t power n minus 1 dt is equal to gamma of n. Now you can go one step further, which is equal to n minus 1 factorial. Okay, so this can be the final answer. So they can ask the question like this: show that this is equal to gamma of n, or show that this is equal to n minus 1 factorial. But you got to substitute back. But we know that t is equal to x squared. Why? Because we took the substitution that x is equal to root of t. So this implies, substitute the values. This is going to be equal to integral 0 to infinity e raised to the power negative x squared times x to the power 2 raised to the power n minus 1 times my dt, right? So my dt is going to be equal to, also we got dt divided by 2 times t power half is equal to dx. So this means dt will be equal to 2 times t raised to the power half times dx. T is actually x squared raised to the power half times dx, which is going to be 2 times x dx. This is my dt. So this is 2 times x dx. On the right side, this is equal to gamma of n, which can also be equal to n minus 1 factorial. So this can be simplified. So, and you can rewrite this as 2 times integral 0 to infinity e raised to the power negative x squared times x to the power 2n minus 2 times x times dx is equal to gamma of n is equal to n minus 1 factorial. So this is nothing but 2 times integral 0 to infinity e raised to the power negative x squared, and x and minus 2 can be simplified, giving me x raised to the power 2n negative 1 times dx is equal to gamma of n is equal to n minus 1 factorial. So just is the final answer.